Hello, everyone. In this video, I wanted to go over something called dimensional analysis. And this is something that helps us make sense of conversions between different units of measurement. It comes up in physics, and it comes up a lot in chemistry. And this is a particular topic that one of my chemistry students wanted me to do a quick recap on, so I'm happy to do it. So I feel like the best way, like many things, the best way to illustrate this topic is through some examples to get a feel of why it's really useful, how to set up the problem, and how to carry it out to the end. So I want to start with a really simple example, just to give you a rundown on how dimensional analysis works. So it's based on facts, collecting facts and using those facts to convert between the unit of measurement that you're given and the unit of measurement that you're trying to get. Oftentimes, it takes multiple jumps to get from your given unit to your desired unit. Sometimes you have to go from your given unit to one unit, to a different unit, to a different unit, and sometimes more than that until you get to the unit that you're trying to get. So in this case, in this really quick, simple example, we're trying to go from decameters, DAM is decameters, that's a metric unit, to centimeters, another metric unit. So I chose a somewhat simple example just to give you a rundown on how the process works, and then we might go into a bit more complicated examples. So whenever we're dealing with metric units, we use this handy little mnemonic device right here. And the way I remember this is King Henry died by drinking chocolate milk. Yeah, it's silly, but it helps me remember all of the metric units that I might need to know. You can come up with your own euphemism or you can use mine, as long as you can remember that it's kilo, hecta, deca, your base unit is B, and then we have deci, centi, milli. Those are the units that we're going to be using in this video. And they can apply to many different types of measurements. They could refer to meters, which is length, of course, and they could also refer to liters, among other things. They could also refer to seconds, and even units of digital storage, like a gigabyte, for example. Gig is not on here, but you could also have a kilobyte, a decabyte, millibyte. Many of these different types of units can be applied to many different types of measurements. So we're trying to convert 0.25 decameters to centimeters. I like to start by listing all of the facts. So we are given 0.25 decameters. And the fact that's really going to come in useful is how many decameters are inside 1 centimeter or vice versa. And one more thing, it's really easy to get confused between capital D and lowercase d. So I want to just write off the side of the screen what each of those means, just to make sure we don't get confused. So capital D is decameters, DAM for short, and then lowercase d is decimeters. That would be DM for short. So like I said, it's really easy to get confused between those two. So you want to make the distinction right away that capital D is decameters and lowercase d is decimeters. So for our fact, we're going to use this mnemonic device to figure out how many decimeters, or I'm sorry, how many centimeters are in capital D, are in decameters. So this is where things get kind of mathy, for lack of a better word. We're going to be dealing with a lot of place value. We're going to be dealing with a lot of multiplying and dividing by powers of 10 to get from where we are to where we want to go. So we're trying to go from DAM to decameter, from decameters to centimeters. So decameters is right here. We put the decimal point after the unit that we have. And then we're going to count however many jumps it takes to get from where we are to where we're trying to get. So it takes 1 to get to the base unit, 2 to get to decimeters, and then 3 jumps to get to centi, which is where we're trying to get. Decameters to centimeters is going to take 3 jumps. So that would be 10 to the 3rd power, because it's 3 jumps. So that would be 10 to the 3rd power of the smaller unit, which is centimeters, can be made from one of the big unit, which is decimeters. So 3 jumps would be 10 to the third power. That would be 1,000 centimeters. So that tells us that there are 1,000 centimeters in 1 decameter. That is the fact we need to know to carry out our dimensional analysis. And dimensional analysis is really kind of visual, which is what I like about it. It makes pictorial sense. It makes visual sense of why we're doing the things we're doing. So we start off with this thing that looks kind of like a table. We have a bunch of cells, and the more facts you have, the more cells you're going to have. So in the topmost left cell, you always put the quantity you're given. So in this case, we are given 0.25 decameters. And then in all the other cells, we put the facts. So this is one column. If we had multiple cells, we would have multiple columns and multiple facts. So this would be one fact. This would be another fact. We need one column for each fact, but in this case, we only have one fact, so we only need one additional column. So our fact tells us we have 1,000 centimeters for every 1 decameter. And that's one thing about the fact. You have to make sure that what's on top is equal to what's on the bottom for every column, for every fact column. 1,000 centimeters is equal to 1 decimeter. And you have to make sure that the thing that you're trying to get is on top of the fact. So we're trying to get to centimeters. That's our goal. That's our destination. So that's why centimeters goes on top instead of decameters. So now that we have that, we need to just grind through the math and then figure out what units we're going to have left after we finish all the math. So every time we move to the right, we multiply. And then every time we move down, we divide. So we're going to deal with our numbers first and then our units. So we have 0.25 times 1,000, and then we have that number divided by 1. Move to the right, we multiply. Move down, we divide. So we have 0.25 times 1,000. And then that just divided by 1. So multiplying by 1,000 is pretty simple. We just move the decimal place 3 times to the right. So that means we're going to have 250. And 250 divided by 1 is just the number itself. Anything divided by 1 is itself. So now we have our numeric answer, and now we need the units. So decameters on top, well, actually, I want to kind of do this off to the side. So we have decameters times centimeters. Divided by decameters. Just like with math, whenever you have a fraction, whatever happens on the top cancels with the same thing if it happens on the bottom. So if we have decameters on top, that's going to cancel with decameters on the bottom. So that means our final answer is going to be 250 centimeters. So that is our answer. So that's how we do dimensional analysis to do quick unit conversions. So we figured out that 0.25 decameters is equivalent to 250 centimeters. Okay, so now let's try a bit more of a complicated example. So for our next example, we're going to be converting kilometers to inches. So notice how we have kilometers, which is a metric unit. That would be the K right here in our little mnemonic device in our metric conversion trick. But notice how inches is not on there. That is because inches are not metric units. Neither are feet, neither are miles. So we can't use this little trick to go directly from kilometers to inches. But there is a separate fact we can use to get there. So we can't go directly from kilometers to inches. So instead, what we're going to do is we're going to go kilometers to centimeters, and then we're going to go centimeters to inches. So the very first thing we should do is figure out how many how many centimeters are in kilometers, are in 1 kilometer. So a centimeter is smaller than a kilometer. So it's going to be a big number of centimeters inside of 1 kilometer. So kilometers is what we're given. It's going to take us 1, 2, 3, 4, 5 jumps to get from after kilometers to after centimeters. That's 5 jumps. 10 to the 5th is 100,000. So it's going to take 100,000 centimeters to make up 1 kilometer. So we have our first fact. So we're given 550 kilometers. And our first fact we have is 1 kilometer is equivalent to 100,000 centimeters. That's the first fact. But notice how we're trying to get to inches. So we're going to need one more fact to take us from centimeters to inches. So our next fact is going to be, it takes 2.54 centimeters to make 1 inch. So we have all the facts we need in order to keep going, in order to proceed. And I know that because we want kilometers, which is what we're starting with. We go from kilometers to centimeters, and then centimeters to inches. And inches is what we're trying to get in the end. So not only are we starting and ending in the place that we're trying to go to, but we have all the right middle conversions needed to get there. So in this case, our middle conversion is centimeters. So we have everything we need. We have all of our facts we need in order to proceed with the dimensional analysis. So this time we have 2 facts. So we're going to have the top left cell for our given information. We're going to have 2 fact columns this time because we have 2 facts. So we are given 550 kilometers. And we're going to use the fact that 1 kilometer is equivalent to 1,000 centimeters, but this is not the right way to set up the fact. Notice how we have kilometers on top for the given information. We also have kilometers on top for the adjacent fact, the fact next to the given information. So it doesn't work out because if we did kilometers times kilometers, move to the right, we multiply. So kilometers times kilometers is kilometers squared divided by centimeters. And that's not what we're trying to get at all. We're trying to end up with centimeters for the first fact and then inches after the second fact. So I did not set this up right. What I should do instead is reverse the order. I should put centimeters on top and kilometers on the bottom. So for our given information, we have 550 kilometers. And then we have the fact that 100,000 centimeters is equivalent to 1 kilometer. And then for our next fact, we know that I'm going to put inches on top because that's ultimately what we're trying to get. We always want to put your desired unit on top of your last fact column. So 1 inch is equivalent to 2.54 centimeters. So now we do the math and then we deal with the unit. So just like last time, every time we move to the right, we multiply. Every time we move down, we divide. And then we go back to the top cell of the next fact. So we multiply by this, we multiply by 1, and then we divide by 2.54. So we multiply by 100,000, divide by 1, multiply by 1 inch, and then divide by 2.54 centimeters. So I'm going to use a calculator because I'm a lazy person. We have 550 times 100,000. And then divide by 1, multiply by 1, and then we're going to divide by 2.54. And we get a very big number. The number we get is 21,653,543.3070866. And typically what I like to do with decimals in this case is figure out the maximum number of significant figures after the decimal place in all the numbers in our table. So this one doesn't have a decimal, so it doesn't count. Neither does this one. Neither do any of the ones. The 1 kilometer and the 1 inch, none of them have a decimal point. This is the only number that has a decimal point. And notice how it has two significant figures after the decimal point. So I want to round my answer to also have two significant figures after the decimal. I always round, just out of general principle, I always round to the maximum number of significant figures after the decimal that I see in all of my numbers. In this case, the maximum places is 2. That's the maximum number of sig figs after the decimal. So we have 21,653,543. And then if we round to two significant figures after the decimal, 0.307, that's going to round to 0.31. And then our units are going to be, well, kilometers on top cancels with kilometers on the bottom. Centimeters on top cancels with centimeters on the bottom. So we're left with just inches, which is exactly what we're trying to get. All right, so this is our answer. 653,543.31 inches. So that's how many inches you can make with 550 kilometers. All right, let's do one more example. Okay, so I think this is going to be my last example in this video, and it's a bit of a tricky. There are quite a few steps and quite a few facts to consider. So we have a house. The area of the house is 1,505 square feet, and we want to convert this amount into square millimeters. So we need to figure out, first in linear units, things like feet, inches, and all the metric units, how to go from feet into millimeters, and then we're going to deal with the square part of all this. And you'll see exactly what I mean in a minute or so. So I want to start writing facts for linear units, things that can be measured with a ruler or a yardstick or anything that measures a length. So we're given feet. We are given 1,505 square feet. And first, we need to figure out how we can possibly go from feet to millimeters. So we don't have feet in our little trick right here at the top because feet are not metric units. So it's best if we go feet to inches, and then inches to centimeters, and then centimeters to millimeters. So it's, like I said, it's going to take quite a few steps. So we're going from feet to inches. So I'm going to start with the fact that 1 foot is equivalent to 12 inches. And then from there, I'm going to use the fact that 1 inch is equivalent to 2.54 centimeters. And I'm leaving spaces because I also want to include the square units. And I'll do that a bit later. And then for our final fact, I'm going to use our little trick up at the top to figure out how many centimeters or how many millimeters are inside of a centimeter. So centimeter is here. It takes 1 jump to go to a millimeter. Millimeters are smaller than centimeters. So it's not going to be 10 centimeters inside of a millimeter. It's going to be 10 millimeters inside of a centimeter because it takes 10 of the smaller unit to make the bigger unit. And whatever is on the left is the bigger unit. Whatever is on the right is the smaller unit. So it takes 10 millimeters to make up a centimeter. So that's our fact. 1 centimeter is equivalent to 10 millimeters. So now we're going to deal with the square units. So I want to figure out how many square inches there are in 1 square foot. So I'm going to use a picture to help me out a little bit. So I'm going to draw a square. In this square, not drawn to scale, of course, but it's 1 foot by 1 foot. So the area of the square, 1 times 1 is 1 square foot. So the area of the square is 1 square foot. But what if I wanted to figure out how many square inches it is? So instead of making it 1 foot by 1 foot, I'm going to rename it. I'm going to make this 12 inches by 12 inches. And we still find the area the exact same way as we did before. We're going to multiply the base times the height to get the area. So 12 times 12 is 144. So the area of this square in feet is 1 square foot, but in inches, it's 144 square inches. So we know that 1 square foot is equivalent to 144 square inches. All right, now I want to do the same thing for square inches to square centimeters. So I'm going to make another square. Actually, I'm going to keep this one. Can I? No, I'm just going to make a new one. Some things Zoom just does not let me do. So I'm going to make another square. And this time I'm going to make it 1 inch by 1 inch. So if we take the area of this square in inches, 1 times 1 is 1. So the area of the square is 1 square inch. But I want to figure out how many square centimeters it is. So instead of labeling it 1 inch by 1 inch, I'm going to relabel it. I'm going to make it 2.54 centimeters because that's however many centimeters are in 1 inch. So the height is 1 inch or 2.54 centimeters. And then the base is going to be the same thing. The base is also 1 inch. So that can also be rewritten as 2.54 centimeters. So 2.54 times 2.54 is 6.4516. So that's how many square centimeters are in 1 square inch. So that's our next fact. We now know that 1 square inch is equivalent to 6.4516 square centimeter. And then we need one more fact. We need to convert from square centimeters into square millimeters. So I'm going to use the same square this time because I didn't write on the inside. I don't have to erase it. So this time I'm going to label it 1 centimeter by 1 centimeter. So the area 1 times 1 is 1. So this is going to be an area of 1 square centimeter. But I also want to figure out the area in millimeters. So we know that a centimeter is equivalent to 10 millimeters. So the height is 10 millimeters. The base of the square is also 10 millimeters. 10 times 10 is 100. So the area of this square is 1 square centimeter or 100 square millimeters. So that is our last fact. We need to carry out the dimensional analysis. So we now know that a square centimeter is equivalent to 100 square millimeters. So now I believe we have all the information we need to do the dimensional analysis and convert our amount of square feet into square millimeters. So we don't need the linear facts anymore. We don't need this. We don't need that. And we don't need that either. All we need are the square units because we're trying to go from square units to square units. We need the linear units to get the square units. But now that we have the square units, we don't need the linear units anymore. So they become not just linear facts, but just general facts. And we're going to be using the squares out of all of those. So we have 3 facts. So that means we're going to need 8 cells. 1 cell for the given information. And then the remaining 6 cells that aren't being used, the 6 cells that are being used, excuse me, are going to be the fact columns. So we're given 1,505 square feet. And then we have our fact. So I'm just going to fill everything out right now, and then we'll talk a little bit through it. So we have square inches. And then we're converting square inches into square centimeters. And then we are converting, it's not going to let me do that, is it? Nope, it's going to be difficult. Okay. So then we have square millimeters as the answer that we're trying to get. That's our final unit that we desire. Okay. So we know that there are 144 square inches in 1 square foot. And we know that there is 1 square inch in 6.4516 square centimeters. And we know that there's 1 square centimeter in 100 square millimeters. So these are all square units. And like I said before, every fact column should be set up in a way where what's on top is always equal to what's on the bottom. I always like to be in the habit of checking that, because if that's not true, if that's not the case, if what's on top is not equal to what's on the bottom, then it means we made a mistake. We need to go back and fix it. So this fact is true. This fact is also true. And then this fact is also true. So we know we're good. We're good to go ahead and do the math. So we're going to multiply by 144. We're going to do 1505 times 144. Divide that number by 1. Multiply that number by 6.4516. Divide that number by 1. Multiply that number by 100, and then divide that number by 1. So we have 1,505 times 144 times 6.4516 times 100. And we get a pretty big number. The number we get is 139,819,075.2. And now I want to go and make sure the units all make sense and we get the unit that we're trying to get. So square feet on top cancels with square feet on the bottom. Square inches on top cancels with square inches on the bottom. Square centimeters on top cancels with square centimeters on the bottom. And we're left with square millimeters, which is exactly what we're trying to get. They ask us how many square millimeters is this, and that's what we have. So we know we did things correctly. So our answer is going to be 139,819,075.2 square millimeters. And I know it doesn't have that much significance, but just out of habit, I like to, just like I did in the last example, I like to put two significant figures after the decimal place, or 2 place values. The zero is, actually, yeah, the 0 is a significant figure. So I'm going to do 2 significant figures after the decimal place. Actually, you know what? I'm going to do 4, because this number also has 4. And it's not necessary, but I just like to be in the habit of doing that, because later on it's going to come in useful. So it's going to be this many square millimeters. And let me think, I thought this might be the last one we want to do. And actually, I lied. I think we should do one more. Something that relates more to physics. So I did lie. I thought that the last example was going to be the last one for this video, but I decided to just do one more. Yes, I lie. Yes, get used to it. So this time, it's a bit trickier because we're dealing with physical quantities that aren't exactly tangible. So a length is something that you can see. You can measure a length on a ruler or a yardstick, and you can get a visual idea of how long something is. You can't measure like speed, for example, or velocity in the exact same way. So that doesn't mean that the process isn't going to be very similar. So the process is going to be nearly identical to what we did in the last few problems. But this time, we are converting from miles per hour. That's miles over hour. It's a rate of how many miles it takes, how many miles can be traveled in 1 hour, It's a rate comparing one thing to another. And we are converting that into kilometers per centisecond. So it's one unit of speed being converted to another unit of speed. So speed or velocity is distance over time. So miles is a distance, kilometers is another unit of distance, hours is a unit of time, and then did I really put centimeters? Get it together. So hours is a unit of time, and centiseconds is another unit of time. So I'm going to approach this a little bit differently than I did the last ones. I'm going to approach this in the sense that I'm going to convert the distances first, and then I'm going to convert the times. So just like last time, I'm going to start by collecting all of the facts. But this time I'm going to have a list of facts for distance. And then I'm going to have a list of facts for time. And I'm going to do the conversion separately for distance and time. So for miles and kilometers, it's pretty straightforward. 1 mile is equivalent to 1.61 kilometers. And that's actually the only fact we need for the distance, because we're trying to convert from miles to kilometers. We can get there with just one fact. So now I'm going to gather the facts we need to convert from hours to centiseconds. So hours is not a metric unit. You might be tempted to look at the trick we have up at the top of the screen and say, hey, this H is hours, but that's not the case. H is the prefix for hecta. So this would be hectometers, hectograms, hectabytes. The prefix hecta for any metric unit is what's represented by this capital H. So that is not hours. So in order to go from hours into centiseconds, we're going to want to go from hours to minutes, minutes to seconds, and then seconds to centimeters. So our first fact, we know that 1 hour is equivalent to 60 minutes. Our second fact we know is that 1 minute is equivalent to 60 seconds. And then we need one more fact. And we're going to use our trick at the top of the screen to tell us how many centiseconds are in a second. So seconds doesn't have a prefix. So centiseconds does have a prefix. If we had centiseconds, or maybe milliseconds, centi and milli would be the prefixes. But in seconds, there is no prefix. And whenever there's no prefix, you know that's going to be your base unit. So seconds is our base unit. And we're converting from our base unit to centiseconds, seconds to centiseconds. So the decimal after our base unit goes here. And then it takes 2 jumps to go to centiseconds from just seconds. So that's going to be times 10 to the second. That's 100. There are 100 centiseconds inside 1 second. So that's our final fact we need. 1 second is equal to 100 centiseconds. So now that we have all of our facts, we're going to set up our dimensional analysis. So we have 8 facts. Now we have 4 facts this time. So we're going to need 10 cells altogether. We're going to have 1 cell for the given information, and then, 1 column for the given information, and then 4 additional columns for all the facts. So that's going to be 5 columns altogether, 10 cells altogether. Sorry if you have OCD and the varying widths of the bars are driving you crazy. They're kind of driving me crazy, but I don't want to be here all night, so I'm just going to leave it as it is. So we're given 65 miles. And we also have hours attached to that. So the word per, like I said, indicates a rate. So this is a number of miles per hour. It's a number of miles traveled for every hour. So whenever you have a situation like that, whenever you have one thing per another thing, you write it like this. It's going to be the first thing over the second thing. So it's 65 miles over 1 hour. So 65 miles over 1 hour. And then for our next fact, we know that 1 hour is 60 minutes. And then after that, we know that 1 minute is 60 seconds. And then I think I made one column too many. No, I don't think I did actually. And then we know that 1 second is equivalent to 100 centiseconds. And then we have one more fact we need. So we dealt with all the time. We still need one more fact for our distance. So we know that 1 mile is equivalent to 1.61 kilometers. And kilometers is what we're trying to get. So I'm going to put that on top. I'm not going to do miles over kilometers. I'm going to do kilometers over miles. So we have 1.61 kilometers is equivalent to 1 mile. So now we do the math. So we're going to do 65 divided by 1 times 1 divided by 60 times 1 divided by 60 times 1 divided by 100 times 1.61 divided by 1. So 65 divided by 60 divided by 60 divided by 100 times 1.61 is a very, very small number. It is, let me move this out of the way first. Whoa, move this part out of the way. That's what I was trying to, or get rid of it. No, there it is. Okay. Just want it out of the way. All right. So what we have is 0.000290,694. So now we're going to see if our units resolve to what we want them to be. So miles on top cancels with miles on the bottom all the way over here. So it doesn't matter if it's a long gap, as long as you have one thing on top and the same thing on the bottom. I know this is miles in the plural, and this is mile in the singular, 1 mile compared with multiple miles. That part doesn't matter. The units still cancel the way they would normally. And it doesn't matter that there's all of this space in between them. The canceling works exactly the same way if they were right next to each other. So miles over miles cancels, and then 1 hour, hours over hours cancels. Same thing with minutes over minutes and seconds over seconds. And what we have left is kilometers on top and centiseconds on the bottom. So whenever we have one thing on top and one thing on the bottom, it's going to be kilometers over centiseconds. And like I said before, another way of saying this is kilometers per second to second. So kind of like you can have a certain number of miles per hour, you can also have a certain number of kilometers per centisecond. It's a rate of speed, just like miles per hour. This is just another way of expressing the same information. But notice how this number is kind of big, kind of hairy looking. There are a lot of digits here. So in this case, I might actually use scientific notation to make this look a little easier, not easier, but a little more manageable, a little easier to look at, I should say. So the way scientific notation works is we take either a really, really small number like this or a really, really big number, and we use exponents to make the number appear smaller and easier to look at. So the way scientific notation works is you always have a number, one significant figure, and then a decimal, and then all of the other digits. So I'm going to figure out how many decimal places it takes to get to one place after our first significant figure. So these zeros are not significant figures. This 2 is. So we have a 2, and then we want the decimal place, and then we want all of the rest of the figures, all the digits, I should say. So it's going to take 1, 2, 3, 4 decimal places to get one decimal place after our first significant figure, which is 2. So to rewrite this answer, it's going to be 2.90694. And then we moved 1, 2, 3, 4 decimal places to the right. So we're going to make this times 10 to the negative 4 kilometers per centisecond. 10 to the negative 4, because it's going to take 4 decimal places. We're going to have to divide by 10 to the 4 to get to where the decimal originally was. So that's why it's -4 and not +4. So that's how many kilometers per centisecond we can travel within the same amount in a scale of miles per hour. All right, so I hope this was helpful. Let me know if you have any questions. And I don't want to make any promises, but I might be making some more chemistry videos in the near future. So keep an eye out for that. All right, hope you guys have a fantastic evening, and I'll see you next time. Ciao.